In this video, we will work on diode examples and their solutions. In today's video, we have this kind of schematic where we're asked to determine VR1, IR1, ID1, IRL, and ID2. So before we answer this type of questions, we must confirm two things. We must check whether our diode they are in forward bias, and check whether which diode is in reverse bias, so that we can know which one to ignore and which one to consider. So now D1 and D2, they are both in forward bias and they are connected in forward bias direction. So so that means we're gonna we are going to consider them to calculate whatever we are asked to calculate. So now, before we start calculating, let's determine the direction of our current, how the current enters a junction. We have two loops on this circuit. We have loop 1, I will call it LP1, and loop 2, I will call it LP2. So we have two loops and we have a junction. On the junction, the current will enter. Remember, the total current, or IR1, it's going to be our total current because it's the one that moves from the V in to this junction. It's going to enter that junction and then leave that junction to IRL, and then that current will flow to ID2, will flow to diode 2. So we are working with silicon diodes with the voltage across the diode is 0.7. So we have IR1 there, and then we have IRL, and then we have ID2. IR1 is entering this junction, then IRL is leaving, and ID2, they are both leaving the junction. So we are asked to determine VR1. Let's start with VR1. Question: what is VR1? VR1, we're going to focus on loop 1 to calculate VR1. Why? Because in VR1, in the loop 1, we have diode 1 and diode 2 series with R1. So we will ignore this loop for now to get the VR1. So to get VR1, we'll focus in this loop 1. So let's see. We know the voltage across diode 1 and diode 2 plus the voltage across VR1, they are both equal to V in. And then we already have voltage across D1 and D2, meaning it's going to be easy to get what? VR1. Let me repeat myself. In loop 1, we want to determine VR1. And in loop 1, we know we have a voltage across diode 1, we have a voltage across diode 2. And then we don't have a voltage across R1, but we have V in, which is our supply voltage. And then voltage law stated the voltage across D1 and across D2 and across VR1. When we add them, they're going to give us what? Total voltage, which is our V in. So meaning to determine VR1, the formula is like this. V in is equals to VR1 plus VD1 plus VD2. That's the voltage. That's the sum of these voltages. They will give us what? V in. So that means we can get VR1 since VD1 and VD2, they are given. We know it's 0.7. And then V in is also given. So let's make VR1 subject of the formula. VR1 is equals to V in minus VD1 plus VD2. Don't forget to put brackets. So now to get VR1, simply we just subtract D1 and D2. Then let's substitute the values. Then VR1 is going to be equal to 20 minus 4.1. So 20 minus 4.1 is equals to 18.6 volts. So VR1 is 18.6 volts. So we answered number 1. So simple. The way we determine VR1, it's very simple, and if you understand what I'm saying, so this is a way of getting VR1. So now let's calculate IR1. Simply, you know, the current of R1 is the voltage of R1 divided by its resistance. So VR1, I mean IR1 is equals to VR1 divided by IR1. It's going to be 18.6 divided by 5.6, meaning is 5,600 ohm. 5,600 ohm. The value of the current is equals to 3.23 milliamperes. 3.32 milliamperes. That is the current for IR1, which is the total current in loop 1. Since ID1 and R1 the series, they share same current. So I can conclude by saying ID1 is equals to IR1 because they are series in loop 1, meaning they share same current. So now let's determine ID1. ID1 is going to be equals to IR1. So the current is the same, which is 3.32 milliamperes. So what is IRL and ID2? So to determine IRL, remember IRL will focus on loop 2. Then in loop 2, how can we determine IRL? If you check RL and D2, they are parallel. So if RL and D2 they are parallel, then what is the voltage of RL? So simply, since D2 and RL they are parallel, meaning the voltage across RL is also the same as the voltage across D2. Meaning that means VD2 is equals to VRL, both equal to 0.7 volts. Since VD2 has its voltage, then the voltage across RL is going to be 0.7 volts. Why? Because it's parallel to RL. So IRL is equals to VRL divided by RL. 0.7 divided by 3,000 3,300 ohm. The current is 0.212 milliamperes. The current is 0.212 milliamperes. That's IRL. So the difficult part is to determine ID2. That it's challenging and trick, but if you're gonna follow what I'm doing, you'll see it's very simple. So ID2, I've drawn the direction of currents. The current that will enter a junction is IR1, and the current that will leave a junction is IRL and ID2. So since we have a junction there, I in is current that is entering a junction is equals to I out. I out is a current that is leaving a junction. So on this junction, IRL and ID2, they are leaving what? A junction, and IR1 is the one that is entering a junction. That means the sum of IRL and ID2, they are equal to IR1. Therefore, IR1 is equals to ID2 plus IRL. So now to determine ID2, I will simply make ID2 substitute of the formula from this equation I've just derived there. So ID2 is going to be equal to IR1 minus IRL. So now the value of ID2 simply 3.32 milliamperes minus 0. Minus 0.212, 3.32 milliamperes minus 0.212 milliamperes. Therefore, ID2 is equals to 3.11 milliamperes. That's it. So to answer or to answer or calculate questions based on diodes and application circuits, you just need to know how to draw a direction of a current and then their relationship, and then have that thing in mind. A diode has 0.7 volts present. So you must know if a diode is in forward bias or reverse bias, what should I do? I've uploaded 2 videos based on diode and application. I've explained how do we ignore that 0.7 and how do we consider 0.7. So this is just an exercise, and that's it for today's video. Please, if you learned something, subscribe, share, comment for more videos. See you in the next video. Thank you.